Okay, so we want to talk, I want to do a little bit of work introducing arc-trig functions. And these are also known as like inverse trig functions. So for example, like I'm going to give, we know that if I have this equation, e to the x is equal to y, that is equivalent to this equation that natural log of y is equal to x, right? And then I just define natural log to be the inverse function of e to the x. Okay, so I'm going to do the same thing here, and I want to do it first for sine of x, so you can see how that works. So I'm going to define the inverse sine function. And the notation for this is one of two things. Either you will see sine with a little -1 of x, or you will also sometimes see this notation, arcsine of x. People use this notation here because this sometimes gets people confused. Like this means the inverse of sine, but sometimes the exponent of -1 just means 1 over, right? And so this is not what this means. And it does mean the inverse function. And those are, one is the reciprocal and one is the inverse. And they're different things, different objects, and they do different things. So just so you know, I like to use this notation myself just so that things don't get confused. But you'll kind of see, you'll see both notations in different places. Okay, so, and then I want to remember what the sine function looks like. So I have something like this. And I know it goes, let's say, 0 to 2 pi. And here's 1. And here's -1, right? And sine as a function passes through 0. And at pi over 2, it's 1. At pi, it's 0. At 3 pi over 2, it looks like this. And if we wanted to go back, minus pi over 2 minus pi in the reverse direction, I would get something like this, right? And this function is periodic, so it just repeats the period. Fundamental period for sine is 2 pi, right? So I look like this. Okay. Now you'll maybe remember that in order to define an inverse, I need functions to be 1-to-1, meaning a 1-to-1 function is a function where each output like originates from exactly one input, right? So you don't have multiple outputs coming from different, you don't have the same output coming from multiple inputs. So we know, and the 1-to-1 functions are also functions that pass both the vertical line test, that's the test to be a function, but also pass the horizontal line test, which is the test to be 1-to-1. And for sure, the sine function does not pass the horizontal line test, and sine is not a 1-to-1 function. Okay, so in order to define the inverse trig function, what we want to do is we want to restrict the domain in order to define this function. what I really want to do here is restrict the domain. I'm going to go back there. So I have this guy. And do you see, I'm going to restrict it to right in this piece from minus pi over 2 to pi over 2. And do you see that red portion of the graph is 1 to 1, right? So I'm going to restrict y equals sine of x. And I'm going to say that x has to be between minus pi over 2 to pi over 2. And for this restricted function, so again, the idea here is now this blue function kind of goes away. I really am just thinking about the red function as this function. For that function, I can define an inverse, okay? So for the restricted function, I can define an inverse. Right? So I'll define this inverse that y is equal to arcsine of x. And that equation is equivalent to the statement x is equal to sine of y. Right? So I'm just doing the same thing, switching inputs and outputs. This equation is sometimes very helpful to think about. And then I want to say, okay, where the input of arcsine has to be between minus 1 and 1. That's because the range of this red function, right here, this is the range, is between minus 1 and 1. And the domain is here. And we remember that domains and ranges get swapped when I define inverses, right? So negative 1 to 1 is now my domain for this inverse function. And where y is between minus pi over 2 to pi over 2. This is the range. And the main thing that maybe is helpful, or maybe the thing that I always think about, is that I think that arcsine can only spit out or create output values between this range. And people routinely think about this on the unit circle. So we have the unit circle, I'm not even going to draw it that well, but that the outputs for arcsine are over here. From this is being minus pi over 2, and up here being pi over 2. Okay, so I want to do an example like this so that you can kind of see what's going on. So, for example, let's say that I just want to find arcsine of, let's say, how about 1? That's good. Now, typically, again, I'm thinking of these functions, and maybe I'll also just say this. So I have these two kind of functions. Sine of x is equal to y, and arcsine of x is equal to some other y, right? The input for sine here, right, is an angle. But the output for arcsine is an angle, right? So I'm swapping them. So you're really thinking here, this arcsine of 1, this is the ratio of the SOHCAHTOA. So a sine is opposite over hypotenuse. And what I have is that guy is 1, right? Okay, so when I want to find this, let's say that I want to find arcsine of 1, And let's say that I'll just name this value y. This is the same equation, and people routinely find it easier to think about this, that they are solving this equation. Like, where is sine equal to 1? But then also I have to remember that y has to be between minus pi over 2 and pi over 2. Is this okay? So I'm thinking of this right half of the unit circle, and I'm thinking to myself, okay, where is the y value equal to 1? And we should get that that value is right up here at pi over 2, that this coordinate is 0, 1. That's where sine is 1. So arcsine of 1 should be just pi over 2. And that's literally the answer that I'm looking for. Is that okay? Now, let's do maybe another one. Okay. Let's do arcsine of negative 1/2. Again, because we have defined this as a one-to-one function, these only have singular outputs, right? So arcsine of 1/2, again, in my head, I'm going to think, okay, this is the same thing as solving this equation, that sine of something is equal to negative 1/2. And also then I'm going to go ahead and like get my unit circle and think about it's negative 1/2 and its sine. So it should be this angle right here. So, and I'm thinking backwards. So like this for sure is 0 radians. And I'm going backwards. This should be the reflection of this guy, which is pi over 6. So this should be minus pi over 6. Right there. Is that okay? And the main thing, and I know, again, maybe I'll say over here, there's another angle that has sine that solves this equation if I'm ignoring the restriction on the domain. But for when I'm really starting with this equation only has one solution. So I get that this over here, what should this be, like 7 pi over 6? That 7 pi over 6 also solves this equation, this one on the right, but it's not the arcsine of negative 1/2. The arcsine of negative 1/2 has to live in this sphere, the right side of the unit circle. I want to do one more thing for arcsine, and then we'll go to the arc cosine. So I want to remind you, for inverse functions in general, we know that two functions are inverses if f of f inverse of x, if I compose them and I get back to the original input, right? So this is, I put x into the inverse function, it spits an output, I put that output back into the original function, and it should bring me back to x. And if also that f inverse of f of x is equal to x. So this is why, again, when you compose natural log and e to the x, so when I have natural log of e to like the x squared, this is just x squared. Because I'm composing two functions, I put e to the x squared into natural log, and these are inverses, so they undo each other. The same thing as if I did e to the natural log of x squared, that's also just x squared because they are inverse functions, and that's another form of composing them, okay? So the same thing should hold true, again, for these functions. So for sine and arcsine, right? So I have this is true. So I have sine inverse of sine of x, when I compose these, is equal to x, as long as, again, x lives in my restricted domain. So this is kind of a thing that happens where you can plug a number in here, and maybe I should put only if, and it might give you a different output. And then I have sine of sine inverse of x is equal to x, as long as, in this case, your inputs are between -1 and 1. Okay. So I want to just do a couple examples so you can see what this looks like and where this equality might not hold. So let's do problem 1. Sine inverse of sine of pi over 8. Again, pi over 8, and this is just find the value, like find the output. Pi over 8 is not, I mean, it's on the unit circle, it's just not like one of the major values that we know, but it's somewhere over here for sure. For sure, it's between minus pi over 2 and pi over 2. So my output should just be here, pi over 8, because these are inverse functions, and because right here, this original input is in the restricted domain. Okay? So, but it doesn't work the same if I do something like this. Sine inverse of sine of, let's do 5 pi over 8. So 5 pi over 8, so over here, this is pi over 8. 5 pi over 8 is past pi, it's pi over 8 past pi over, okay, this is what I'm really thinking about. This is pi over 8 plus 4 pi over 8, just to kind of get to see, because this 4 pi over 8 is the same thing as pi over 2. So here's pi over 2, and then I go another pi over 8 past this, right? So this is 5 pi over 8, this fractional thinking. And what I have here now is this input no longer lives in the designated restricted domain. So what I really need to do is think about what angle that is in this red sphere, in this red area, will give me the same sine value as 5 pi over 8. So you can kind of see right here, I'm looking for this, like this is my sine value right here. And if you just map this back over here, and you'll see, if I had drawn an actual circle, you'll see another angle right there that's just pi over 8 less than pi over 2, where the sine values are the same. So I don't really need to find this sine value to figure out what the arcsine of this sine is. Like, I don't have to actually compute this intermediary output. I just have to say, hey, it's definitely going to be this angle. This is going to be symmetry, so this should be 4 pi over 8, now minus pi over 8, or 3 pi over 8. So this one doesn't spit out the same thing because I'm not in the original restricted domain that I started with. Okay, I just want to do maybe one more of these for sine. Yeah, let's do this one. Yeah, how about let's do sine inverse of sine of, let's do, how about 11 pi over 3. How's that? So 11 pi over 3 should be, and I'm just going to think about this, 6 pi over 3 is 2 pi. That's a whole rotation, right? So if I'm looking at the unit circle, that's 6 pi over 3. I go another 6 pi over 3, and that gets me to 12 pi over 3, right? So 11 pi over 3 should be just shy of 2 rotations. So I go, you know, like twice around, and then I come back here by a third. So it should be right there. So the output of this definitely cannot be 11 pi over 3 because it's not between, I mean, even though the point is between minus pi over 2 to pi over 2, it itself as 11 pi over 3 is not in between these two values, right? But we do just need to find the value that's here that is between these two values. So really, again, I'm just thinking like, and if this is sort of all this fractional reasoning, like I'm really thinking up here that this value is pi over 3, and that down here is the negative of that. So this value should also be a negative pi over 3 right there. So the output of this function should be minus pi over 3 because that is in the acceptable range of the inverse sine function or the arcsine function. Okay.